broadcast. There you go.
Oh, yeah.
And then let's I guess Joshua will join us when he joins us.
Yeah, he's been a bit busy these days.
I almost wonder if he works nights or like super late, like evenings, because he was talking about how sometimes it's hard to get up because he's asleep. So I'm wondering if that's what it is. Like, no judgment. I've been there. Working nights sucks. But if that's the case, totally understand that.
Yeah, well, so I think considering Steven's score, Steven, you should run us through this one.
What? No. I was lucky.
He just had a really good calculator.
Yeah.
We need to buy your calculator. I gotta go get
Yeah,
one.
I only use my cell phone, yeah.
What?
What? Okay,
Yeah,
I gotta go get your cell phone. What cell phone did you buy?
I have an iPhone.
I used my iPhone, and that's what he told me was wrong, was my calculations. But I totally used the 3 things, and I did. Oh my gosh.
Yeah, I only use the formula for the Tasha gave us.
Yeah, that's crazy.
Yeah.
Wow.
Well, you're just smarter. There you go.
He understands this.
Maybe what they did is they switched your score, Steven, with Tasha's.
No, I struggled, man. I struggled. I deserved my score.
With all that effort that you put into that document that you didn't get an A.
Right?
Man, I tell you what, work smarter, not harder. I was like, I don't want to stress about this. And so I just kept adding to that thing and decreasing the font and adding more.
Oh, well, I will not argue if you do that again next time.
Allows a piece of paper like that, you can guarantee that I will have one.
All right, so Bartholomew, over to you.
Okay. So who can read very fast? I don't read very fast, so that we can.
The nice thing is the first question's quick, so it's fun.
Yeah. The first question is very hard.
I don't know which one to pick, you guys.
So I'm in question 3. Okay, we get
Do you want me to read?
Yes.
Okay. Which hypothesis involves equality, like equal sign?
I think it's the null hypothesis.
I believe so too.
Yes.
Yeah, it's the null. Because that's... Is that one HO? Yeah, that's the null.
Yes.
Okay.
That's a null.
Information. The p-value, the p-value is the probability of obtaining a sample statistic at least as extreme as the one that is actually observed. Use this information to answer the next question. Remember that the p-value is the probability of obtaining a sample statistic at least as extreme as the one you actually observed. When computing the p-value, which hypothesis do you assume to be true?
Null hypothesis.
Correct. Yeah. All right. Next question. Suppose the null hypothesis is mu equals 10. Use this information to answer the next 3 questions. Which of the following represents the alternative hypothesis for a two-tailed test?
It's the third one.
Yes.
What?
Yes, it's the third one.
We are in question 5?
5.
5.
Okay.
Yeah.
Because because it will be a between figure, so you can't have it. You can't say it's greater than. You can't say it's less than. So it has to be not equal to that number. If that makes sense, I don't know if that makes sense.
If you're looking at the lesson, it's under like subsection 4 or whatever the heck they are, like the 4. And it has it listed out for the two-tailed hypothesis, and it does say that it's mu is not equal to. So it would be that third one.
I think is lock cold. It looks like Joshua's just his computer's updating. That's why I can't come on.
Oh, bummer.
But he said he'll be as quick as he can.
Huh. Mine did that the other day. Like, why are you doing this now?
That sucks. Poor guy.
All right, number 6.
Which of the following represents the alternative hypothesis for a two-tailed test?
Left-tailed.
Left-tailed.
The first one.
What did I say?
You said two-tailed. It's the left-tailed.
My bad, I can't read.
That's the first one.
Agreed.
Less than.
Okay. Which of the following represents the alternative hypothesis for a right-tailed test? Greater than.
The second one.
Yes, I concur.
Indubitably.
All right. Remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance, or whatever that is. Use this information. Oh, that's alpha?
Yeah.
All right. Which relationship would result in a failing to reject the null hypothesis?
I think the first one.
It's the less than alpha.
So when the p-value is less than the level of significance. Huh?
Yeah.
So less than alpha.
Let me quickly check the book again.
Yeah, I think so it's when it's in the far corners, it was saying in the example. So like on the applet, if you move those two red bars or whatever, if the alpha is in, the alpha will be the ones in the corners. It's sort of in the example it was showing.
Okay. Yeah.
Yeah, so when the p-value is less, then we reject the null. If the p-value is not less than, then we fail to reject the null. So I think this is the first one.
Greater than.
If the p-value.
Yeah.
It doesn't say p-value is greater than alpha. The first one.
Yeah.
Yes.
So is that the right one? P-value must be greater than alpha.
Well, it's talking about we fail to reject it. So we're not rejecting it. We just...
We fail to reject the null. So meaning the p-value is more than the level of significance.
Okay.
Because we're not rejecting it, we're failing to reject it. Which means
Correct.
I think
so. It would be the first one.
When we go to the book chapter, the summary,
Yeah.
we can find that one over there.
I don't think you ever reject anything. It said you never reject either way. It said something like that, if I remember right. So you just don't reject it but you just don't accept, like you fail to reject it. In other words, yeah. So
correct.
Something like that, yeah.
So it is that first one. P-value is greater than alpha. All right.
Yes.
Which relationship will result in rejecting the null hypothesis?
Okay, never mind.
P-value is less than.
that would be less than alpha, right?
Yes.
Which relationship would result in rejecting?
Okay. We ready to go to 10?
I think so.
Yes.
All right.
Doesn't make sense.
An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $15 $100. They are concerned that the true mean is actually higher than this. Use this information to answer the next two questions. Which of the following would be an appropriate alternative hypothesis? The average claim amount is greater than 1,500.
Not equal.
Yeah, 3.
Yes.
No.
Yeah.
Yeah, higher than. Yes.
I would say it's 3.
Which of the following would be an appropriate null hypothesis? The average claim amount is equal to 1,500.
Mm-hmm.
Okay. The insurance company randomly selects n equals 40 claims and calculates a sample mean of x bar equals 1,650. Use this information to answer the next three questions.
So just for question 11, it's number 1, eh?
Yes.
Okay, thanks.
What's that?
He was asking about 11. Okay, so the insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? Yes. Because it's over 30. So the sample size is considered large.
Yes. So the first one.
Yes.
Oh gosh, I don't know how you just figure all these out.
Well, because they said in one of the lessons that as long as your sample size was above 30, that's typically considered a large sample.
Yeah.
I don't know why they picked 30. They just did, and so
I think
30.
I'd imagine it's just for the course. I don't know. I wonder if it's for the real world as well.
I have no idea.
Anyway.
And so it would be a good assumption since the sample size is large enough to justify it.
Okay.
What theorem or law justifies your answer to the previous question?
Is that the law of large numbers or central limit?
Central limit.
I think it's the central limit.
I struggle with those two and get them confused.
Central limit because it's the.
Everyone open Tasha's Word document quickly.
Yeah, I get it.
Our sample size. Okay, so it is the central limit theorem.
Yeah, central limit.
Totally looked at my document.
Yeah.
Oh goodness. Okay, which of the following is the test? Oh my gosh, statistic as defined in this lesson. Okay, so.
And we're all sleep deprived, eh?
Yeah. Okay.
N.
So.
N.
No, I think it's the z-score. We are still talking about the probability. So it's the z-score.
Because n is something. Where is the notes?
This, it will be you're saying the z-score. It should be x.
So
Usually.
a parameter is a true but usually known number that describes a population. A statistic is an estimate of a parameter obtained from a sample. So
Yeah,
I'd
if
say
you read the textbook, 4.2.
So one thing that we should remember is that in this lesson, we are also looking at the probability of committing a type 1 error or type 2 error. So we sometimes have to depend on the z-score. So I think it's a z-score. So we need to pick that one, yeah.
And what does S stand for?
What is what?
The S symbol. What's that for?
That's the variance.
Oh, variance. Okay, no. All right, then I think maybe you might be right.
I think it's also the z-score.
Okay, I'll go with that.
Because I don't think it's X bar, and I know it's not N, because N is just
Okay.
a random number that you decide to.
And it can't be X bar because X bar will be the parameter.
So
Correct.
can you open to the textbook 4.2, the test statistic?
Yeah.
I'm scrolling. So in this case,
4.2.
yeah.
Yes.
So it would be the z-score.
Yes.
Okay.
That's what I was saying all along, but Bartholomew wouldn't listen.
Oh goodness.
Sorry, Bartholomew.
All right. Are we good?
Yep.
Okay.
I'm good.
All right. Next one. The historical mean of sales receipts at a grocery store is 150, with standard deviation of $40. The store manager suspects that the average has decreased. She sets up hypothesis test with the hypotheses. The null hypothesis is mu is equal to 150, and the alternative hypothesis mu is less than 150. She will use a level of significance of alpha equals 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes X bar equals 144. Use this info to answer the next 4 questions. What is the z-score associated with this test? So now we calculate out a z-score. Yay! Okay.
I got when I went to go look at the textbook, I got knocked out. What number are we on?
It's 15.
And 14 was Z, eh?
Yes, 14 was Z.
Is there a new z-score calculation that we have to learn?
No, this one you're doing the z-score that has sigma divided by the square root of n.
Then what the heck is the alpha doing?
Have you already done 15 or are you going on to 15?
I just read the whatever about 15.
Okay.
And then we're doing the z-score to solve actual question 15 because it says what is the z-score associated with this test. So now we're calculating the z-score.
All right. So you'd use the mean of the null hypothesis, is that right?
Yes.
So is it the square root of 36? And what does the alpha have to do with it?
I don't know because I just double checked and it's not in this equation. So we'll deal with alpha in a minute. They could have just put alpha in there to confuse us too.
No, I think there is something, isn't it? Also, doesn't it go next? I think I did see something actually about that. Oh, sorry, no, it's just a deviation.
Okay, so if our p-value is less than alpha, we reject the null hypothesis. If it's greater than alpha, we fail to reject it.
Yeah.
So we just, after we calculate the z-score and then we put it into the probability applet, that's when we'll use alpha, but we're not using it for this part of the question yet.
Do you guys get 0.15 for the Z score?
Give me 2 seconds.
Yeah, negative 0.5, 0.9.
Probability or
The C score? I don't know. I did.
Oh, dang it. Hold on. I screwed up.
Yeah, I got negative 0.900.
Yeah, I get the same.
for the that for the Z score?
No!
That is the Z score.
I hate my calculator. It's not letting
Can
me
you
do
use
math.
the Excel?
What did you get, Bartholomew?
0.0, negative 0.900.
So you took 150 minus 144 divided by 40, is that right?
No, you have to take the 144 rather minus 150.
Right, so you get negative 6.
And 40 divided by the square root of 36, and then divide that.
Okay.
Divide negative 6 by that answer.
I got 0.474.
No.
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 Negative 6 divided by 6.66666666. And then you get the answer of negative 0.90000.
Oh, dang it, son of a twin. I'm so mad, I can't. Okay, we're going to try doing this one more time. Getting so angry. There we go. Now I have negative 9. Or 0.9.
It's about time.
Oh, okay.
Wait, but it says round to 3 decimal places. I have 1 decimal place. How did I screw up? What's the answer? I'm done.
0.900.
Negative 900.
I hate math. What is the p-value associated with the z-score from the previous question? All right, so now we put in the z-score.
Put it in where?
In the normal probability applet.
I don't have that applet up. Where's it at?
The one that we always use, the blue and white thing.
I don't have it. Where's it at?
At the very top of the quiz, it should have it in blue letters. And you should be able to open it.
No, it's not here. But if you just type in your search history, it should probably come up if you if you type in applet. If you keep your search histories.
So then we have to share. What did I am getting?
Okay.
0.184.
What are we highlighting, Bartholomew?
We are highlighting the left side.
Why?
Yeah, because it's a negative.
So you're just highlighting on that very left side, all by itself.
Oh, wait, okay. No.
0.184.
Need for.
Yep.
I'm so glad we got clever people in our group.
Me too. This would be rough without them.
I include you in that.
Well, I'm glad y'all smart because I couldn't handle this.
Okay. What inference would you make about the null hypothesis? Okay, so alpha, this is where we use alpha, I think, right?
I think
Are
so.
we on
Yep.
16 or are we
Yeah,
on
we need to compare it.
17.
17? What was 16?
That was
16 was 0.184. It was the area.
That was the first. That's actually the other one. I didn't read the question. Sorry. So 15 is, what is the Z score? Okay, so the Z score is 0.9, negative 0. Do we put in a negative?
Yes.
Yes.
0, 0, 0. Okay, sorry. I'm with you. 17. Oh, have we already got 17 now?
No, we're working on it right now.
Okay.
So since our p-value is more than the level of significance, we fail to reject the null hypothesis, right?
Right. Because
Yeah.
it's
Yeah.
great.
it's greater than 0.05. Sweet. What is your conclusion for this problem?
It's stupid. What?
Oh, heavens. We have sufficient evidence that the true population mean is 150.
Well, I think we have sufficient evidence that the true population mean is less than 150.
Well, but it was still within $40 because the standard, so it was within the one standard deviation of 150 because the amount that she got from her simple random sample of those 36 receipts was 144. That's pretty close to 150. Like, I'd still say that the mean is 150.
Let me consult the textbook again.
To the trusty textbook.
Yeah.
If the p-value is small, that implies that the z-score was very large. In other words, x-bar was far away from mean.
Yeah, our thing wasn't very large.
Ours was small.
So it's a fail to reject.
What do I say? Okay, yeah. If the p is low, reject the null. So how do we decide if the p-value is small enough to reject the null hypothesis? We need a way to determine if there is enough evidence to reject the null hypothesis.
That's what alpha is. So if it's less than alpha, then we reject it. But we were larger than alpha.
We need a number that can be used to determine if the p-value is small enough. The number is called the level of significance and is often denoted as alpha.
So the level of significance, the number that they give to us is 0.05.
Say that
Is that
again.
what it needs to be? It needs to be that size or greater.
I don't understand your question.
Was it 0? Was it 0.5 or 0,
0.05.
0 is 5? Yeah.
0.05.
And our p-value is 18, as opposed to 5.
1.8, 5. Or 0.18.
So it is larger than.
It's either going to be 2 or 4.
I think it's
Well, should we just choose one and then we? I guess.
I am betting on 3.
On 3,
Yeah, that's what I chose.
I think we have sufficient info. I don't think that there's insufficient evidence. I think we have enough evidence that we can make some sort of statement.
Just according to the book, that if the p is low, reject the null. So if the p is higher than the null, so yeah, so we don't reject it.
We're not rejecting it, but that's why we're asking if we have sufficient. What's our conclusion?
We're just trying to decide if it is 150 or if it's less than 150 for the true population mean.
So we reject. When we reject, then it means that we have enough evidence. But if you fail to reject, then it is that we have insufficient evidence.
Yeah, that's what I would say as well.
Well, we can do that.
The third one.
Whatever. The third one. Let's do it. Whatever.
Okay.
Well, should we leave that one for now and we can come back to it?
No, I think we're okay.
You think it's number 3?
Yeah. Because no, it's like there's not enough evidence to show that it's less than 150. So it's not saying she's wrong, but there's just not enough to prove her right either.
Yeah.
Okay. No, I agree with that one. I'll accept that. I concur.
For which one?
Really?
So on 18, the third one, because what it's saying is we're not saying that the mean is 150, but we're not saying it either.
We're not saying it.
To prove her right, which is
So
true.
We're not saying it, and we're not saying it.
Yeah, it's a dumb statement. I got you.
It's really weird. It's not how normal people think.
Statistics.
Statistics is not happening.
All right, 19.
Okay.
There are 2 types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true?
Is it 1?
Type 1.
We can check that. Type 1
Yes.
error. Yeah.
I just read the summary.
Thank goodness for the summary.
I love that piece of info. All right, 20. Does Josh ever appear?
The nice thing is you can also just go onto the recording and just use that to check his work.
Yeah. Okay, 20. A researcher decided that instead of using a level of significance of alpha equals 0.05, he will use alpha equals 0.01. Which of the following will be true?
Oh man, my head hurts.
Okay, what is type? Okay.
Type 1 is the rejecting the null hypothesis when it's true.
I don't think that'll be an issue.
I think the second
So
one.
I think it'd be type 2.
Yes.
Okay.
Because it says that he'll fail to reject the null hypothesis when it's not true.
They're using.
So.
Yeah, because the level of significance is getting smaller.
Right.
So it's going to be more difficult for them to accept the null hypothesis. Is that right?
it'll make it easier for them to accept the null hypothesis because they'll have 0.04 more wiggle room.
They'll have
and
more.
So
it'll decrease the chance of rejecting.
Correct.
No.
So it would be a type 2 error.
Yeah. Man, I really hope we don't get a question like that on like the 29th question of the test. My head will just explode.
Mine's already
Same.
exploded.
Same.
You lost me about 20 questions ago.
Yeah, I think this one is definitely, for this next test, is definitely going to involve some diagrams and stuff, having to draw some stuff.
Diagram?
Yeah, drawing little pictures and anyway.
Something.
Yeah, because I can't think that in my head, especially like right now. Anyway.
True.
Yes.
All right. 21. If alpha equals 0.05, compute the probability of committing a type 1 error. Round to 2 decimal places.
How do we get alpha?
How do we compute?
I hear a lot of punching on the calculator.
I put it into the applet to see if that would make sense. But I don't understand what I'm supposed to do with it, so I don't think that's right. Okay, going to the textbook.
Yeah. So where I am at the moment. Okay, so the p-value is that makes no sense. Come on, Stephen, you're our A student. Give us the answer.
I'm reading the textbook. Yeah, but I couldn't find the answer.
What is it wanting? Compute the probability of committing a type 1 error.
It's probably going to be something really silly.
Okay, let's go. Where does it talk about the errors?
The value of alpha is the probability of committing a type 1 error.
Where are the statistics genius?
So what's that?
Where are the statistics genius?
Yeah, wait, please. I think it was Joshua.
So wait,
Oh, don't we just subtract it by 1? The null hypothesis is equal to, if it's 1, we had 1 and 0. What's between 1 and 0? And so we've got 0.05. So if we subtract that by 1, it's 995. 0.95. Would not be that.
So you'd have a 95% chance of screwing up.
Compute the of committing a type 1 error if alpha is equal to What does alpha stand for? What's the long name for it again? What did they say? It's the significance.
The level of significance.
Okay, so a researcher decides that instead of using a level of... Okay, so yeah, I don't know. Doesn't sound right though.
So in this part, under 4.5, it says that they choose 0.05, and this is equal to 1/20. So when the null hypothesis is true, there's a 1 in 20 chance that it will be rejected at the 0.5 level of significance.
Okay, so it's as close, sort of. But just
But it doesn't tell
95.
me why.
If it's 1 in 20, then it should be. Let's see.
So
yeah.
can we just divide the 0.05 by 1?
That's what. Not divide, just subtract.
I think we should divide rather. Let me, since we have 2 attempts, let me shoot him.
All right. If it's the other thing is if alpha is equal to 0.505, which is 1/20, then it could also 1 divided by 80 possibly. But I think it could be just 1 minus 0.5.
Wait, my magic work, but I don't understand. I got it.
Is it right?
Yes.
So what's the answer?
0.05.
The answer is the same as the alpha.
Yes.
Yeah, I think so.
Okay, that makes sense. Overcomplicating as usual. Yeah, because that's what alpha is. It's the probability of committing a type 1 error.
I hate statistics. It's just so hard.
Please don't let any be wrong. I hope I haven't typed something wrong.
Could you guys just help me do my stuff? That'd be good.
Thank you, Bartholomew. Okay, I'm going to go to bed.
Okay.
Like 7 o'clock here. I think it's time.
7 o'clock? Where do you live?
Yeah. In the evening, yeah, South Africa.
Where?
7 in the evening?
Yeah, I'm in South Africa.
South Africa. Oh, okay.
And yourself, Bartholomew?
I'm in Ghana.
I was going to say, I thought so. Whereabouts? Whereabouts, Bartholomew?
I'm in Accra, Ghana.
Okay, cool. My in-laws, they actually served, they were mission presidents in Kumasi.
Oh, okay.
Yeah, anyway. Yeah, they say there's the best mangoes in the world in Ghana.
You learning?
Yeah, there are pretty big mangoes over here.
Yeah. Anyway. All right, guys. So is there anything else? Are we able to call it a night?
Yeah, I think I'm good.
Yep.
I think
I'm just gonna have to go over everything like 5 times, but I'm good.
maybe if I can make a suggestion is maybe just also use Connor. I think he'll help. It's nice to just be able to talk it over rather than always just reading, you know?
Yeah.
So anyway.
Yay, Josh.
Wow.
Yeah.
That's
So
what
We finally made it.
I knew the computer needed to update. I'm like, okay, my updates usually take 5 minutes. Cool. I'll do that before I hop on. No, decided to take like an hour.
Sorry, man.
I'm so sorry.
Oh, it's fine.
At least we can now say that you attended the meeting.
Yeah.
But does anyone have the answers still? Can we maybe?
I have the answer.
Because Josh, you could either what you could do. Maybe what I did last time was I just went through the video and then just checked after I attempted it.
Okay.
So I don't know if you want to just if that's easier for you.
You would learn more going through the video other than just me telling you the answers. You'd learn
Yeah,
what.
that's a good point. Did y'all finish already, or y'all on the side?
Yeah.
Oh,
We got full marks, so you at least know you got. As long as you
Sweet.
watch the video, you'll get the marks. You just need to
yeah.
get through it.
Cool.
And listen to the whole arguments.
Okay.
When you hear my argument, make sure you carry on listening.
Yeah, always listen. Because that's all you
Cool.
All right, guys, I'm gonna head out.
Bye.
Okay.
Yeah.
Bye.
Well,
Oh wait, so who's doing next week?
I think it's Melanie said she was going to. I don't
Okay, cool.
remember for sure though. I'll
Yeah.
double check. I'll send an email.
Okay, cool.
oh, she already popped up. Well,
Yeah,
guys,
she's like, gotta go.
so